And we're off. SIG-GCP meeting number 2. The only kind of intro I have to make is to broadly apologize for how few meetings there have been between this one and meeting number 1. And that's been to do with a whole bunch of issues to do with calendaring, to do with a set of holidays that came in, and a whole bunch of other stuff. It actually strongly highlights the need for a co-lead for this SIG-GCP. Which is something I'm going to have to try and chase one way or another. And I think anybody who's watching this, if they're interested in becoming a co-lead for SIG-GCP and trying to push this along, please get in touch, because I think that'd be a good thing to try and set up. That said, today's main event is Justin Santa Barbara, who has been plumbing GCP support into COPS, which I think a lot of people are very interested in. So without further ado, hand it over to Justin. Thank you.
Awesome. Thank you, Adam. Yes, so I wanted to show how COPS can support GCP. For people that don't know, COPS is sort of is a cluster management tool. It lets you create and modify the configuration, upgrade, delete all your clusters. And it works on, it started off working on AWS. And we have reasonable support at this point for GCE. We are likely to take that out of, it's still in alpha or feature gated right now. And I think in the next release of COPS, which is coming soon, we will remove that feature gate. So it will be, ready to use. We'll declare it no longer likely to blow up everything or land you in hot water. And we do have, it is under E2E testing. And so we have under the real Google Run E2E, and we have a couple of jobs which are mostly green. We have that, and we have an HA job, which is interestingly less green, but it is mostly a sea of green. And so I want to add a lot more tests to this. But what I will show you is the actual demo. So let me actually kick off the creation of a cluster first. That's probably the easiest or the best thing, because it takes a little while. So we are going to do COPS, create cluster. We're going to give it a name, test.k8s.local, which I'll talk about in a minute. We specify a Kubernetes version. We say master count 3 to do HA masters with 3 masters, and we are going to do it in the zone US East 1B. We could specify multiple zones here if we wanted to do multi-zone, multi-master, but we're going to keep it simple for now. So off it goes, and it's going to do most of the work and figure out, to give us a little preview of what it's going to actually do. There you see some notes, and that is what it's going to go and create. What I'll actually do is I will kick off the creation, and then we'll scroll back through that while it's actually creating the objects. So that actually, oop, my bad. Okay, so that's going to go and actually start doing stuff, running all those tasks. While it's doing that, let's look at what it's actually doing. So COPS has a has a declarative model inside it of the tasks which it's going to run. So, wow, there are a lot of these. So, for example, it is going to create 6 persistent volumes, one for etcd events, one for etcd main, and then 3 masters. So it's going to create all of those. It is going to, it creates an address, which is going to be our IP address for the ingress into the cluster. Some firewall rules. It creates managed instance groups for the masters and for the nodes, and all sorts of different things. But most of the time, you don't really need to worry about this. Oh, key pairs, and it has some add-on management as well. And so scrolling down, okay, so it has gone and created the instances in Google Cloud while we were scrolling through looking at what it was doing, which doesn't necessarily mean that it's actually running yet, but we should be able to see the instances. If you can, it's not great. Let's see if we can make that. Okay, I'm sure. Anyway, we have three master instances, and we have 2 nodes, and we have sort of by mistake a cluster registry. So we're going to try to work with the cluster registry folk to make that behave like the actual cluster registry. You can create multiple clusters. They all live in a what we call a state store, which can be an S3 bucket, a GCS bucket, and coming soon a server using the API machinery. But we use API machinery, so you can do things like, kops get cluster OYAML. You can see the actual API object that we have, which is a real API object with a spec. And our two main objects right now, or our two main types, are clusters, which are the top level object, and instance groups, or IG is what we can type instead. And so you can see that we have in our current cluster, we have 3 instance groups for the masters and 1 instance group for the nodes. We do an instance group per master just to make sure that we are always running one. But that's how it works. And we can also, even while it's booting, we can edit things, of course. And so kops is supposed to feel a little bit like kubectl. And when we actually have the API server running, it will behave exactly like kubectl. But even while it's booting, we can, for example, resize the cluster, the nodes instance group from 2 nodes to 3 nodes. We will save that. If we apply that change, you'll be able to see some silly log messages and then a preview of what it's actually going to do. So it's going to change the target size of that managed instance group from 2 to 3, and you have to specify yes to actually apply the changes. So let's do that. It's thinking. And there we go. And if we now compute instances list, we should see, hopefully, a new instance coming up. Yeah, so we have a 3rd node that's booting up. One of them probably says somewhere, oh, well, that was, GCE is really fast. Okay, normally I catch it before it actually goes into running, but it's already running. So we now have 3 nodes, 2 of which started before and 3 masters. And the moment of truth now, so HA masters are a little slower to start, but if we are lucky, we should be able to, go wide. We're lucky, yay! So you can see we timed that nicely. So we have, our 3 masters have come up. The nodes haven't joined yet. They have been running for about 40 seconds. So, it doesn't take long to boot a cluster and get it all running. And if we watch it, hopefully soon we will see the nodes start joining. Oh, there it is. The first node just joined. Well, lots of nodes are joining, it looks like. So, wow, I need to make this a little smaller. I actually forgot the shortcut. Where's Zoom? Oh well, I guess we'll have to deal with it. Sorry. Okay, so we have looks like 2 nodes right now, not ready. The 2 nodes are ready, and the 3rd node, which we started a little bit early, will join a little bit later. Will join in a minute. But let's do something really evil. So we can of course edit the cluster configuration. And for example, we could change the version from 186 to 187, and we could change the networking mode from KubeNet to the excellent homegrown Copio networking. And now what we can do is we can get a preview of the changes it's actually going to make. So kops update cluster without yes will show us the preview. And it does a bunch of changes to the managed instance groups and to the instance templates. And you can see that it's going to add this add-on, which is Copio networking. And if we do yes, so what this will do is this will actually apply the changes. What it will not do is restart the nodes for you. So what we'll do is we will fire that off, and then we'll roll the nodes, and kops calls that a rolling update. And so if you do, it tells you probably need to do a rolling update. If you do a kops rolling update cluster, again without yes, you'll see a preview of what it needs to do. So it's saying that all 4 instance groups need updates. And if we do yes, what it would do is it would do a drain, a coordinated drain, shut it down gracefully, do it in sequence, run the masters first, all that sort of stuff. That will take probably 20 minutes. So what we can do instead is just blast through it. I can't even see, I'm typing blind. Okay. So what this does is we're just saying to just shut them down as fast as you can. Not drain. Is it cloud only means don't even use the API, just kill them and have it restart. So we're basically shutting down all the masters at the same time, all the nodes at the same time. The managed instance group will replace those with the new version that we just configured. And so in normally there would be no downtime in an HA cluster. With this one, it will be a couple of minutes or a minute or two while those recover. And then it will come back with 187 is what we configured. And also with the new networking configuration, so the new add-on. And so that is what the other thing to complete the picture, lightning demo, to complete the picture, when you're done with your cluster, we're not going to specify yes, but if you cops delete your cluster, you can see, this is really terrible. You can see all the things that you would delete. I'm trying to, so for example, it will go and it will delete a bunch of the things we created, the address, the disks, the firewall rules, the instances, the managed instance groups, and the templates. It will basically clean up after itself, the routes. And one thing you may note is we used a name which was test.kates.local. So that's a relatively new thing, and that uses a sort of gossip DNS mechanism. So one of the pain points of COPS in the past was that every cluster has a DNS name, and that used to be a real DNS name. And so you would have to set up, a real domain name, and that actually was fine for most real-world cases, I guess, or where you're actually running a production cluster, but it wasn't great for people that wanted a cluster that had no public IPs, or was completely behind the firewall, or a development cluster that you didn't necessarily want to go get a domain name and set up Route 53 or Google Cloud DNS to do. So Kates.local triggers a gossip DNS mode, so it's great for development. The nodes will gossip amongst each other and figure out DNS that way. So it's serverless DNS, I guess you'd call it. Let's see though, if we're lucky, let's see if we got lucky twice. This seems unlikely, but we can hope. Oh, silly Justin. Okay, so we weren't quite that lucky. It is possible that looks like one of them might be coming back. But yes, so that's while we're waiting for that. That is the lightning demo of COPS that basically is now working on GCP, and we are going to take it out of alpha in the next version of COPS and add a lot more E2E tests, give us confidence in the various configurations. It is great that we used to be a little bit constrained on the E2E tests in terms of resources. Now we're on GCE, we are less constrained. We're also less constrained on the AWS side because now AWS have stepped up and started doing that. But it would be great, we have an HA test on GCE, which is actually showing what looks like some flakes. I'm not entirely sure, but definitely looks like there's some flakier tests in HA mode. It seems to have gotten a little bit better recently, but definitely some tests that are a little flaky maybe. And we're still running etcd2, so some of that could be fixed in etcd3. So, we can start expanding this test grid, etcd3, etcd2, HA, non-HA, different networking modes, all of this sort of stuff. In terms of COPS, I think the roadmap beyond, more support from more cloud providers and for bare metal is to work on breaking it up into its constituent parts. So the Machines API, I think, Adam, you have a pending question about, which I will let you ask in a minute. But then the other pieces that are baked into COPS right now that I'd like to split out are, etcd management and add-on management. Those are sort of baked into COPS. The add-on management in particular is a little problematic because you would like to work with add-ons without having to use COPS all the time. You'd like to just use kubectl. So hopefully we can reach consensus on that and surface that in a way that every installation program and GKE and EKS and all of them can use, and get more test coverage on everything. And I guess specific to GCP, the features we're looking at, the only remaining features that I know of are IP alias IP ranges and NVMe support. I feel like we should be configuring that. Oh, cool. Anyway, while I was blabbering on, it had restarted. So we now have 187 is running, and if I could get pods, all namespaces, we should be able to see that we are running Copio networking instead of Kubernetes. So we are running a different networking mode as well. And so that's the sort of the workflow of kops, is you create your cluster, you update the specifications, edit the specifications, either with the equivalent of kubectl edit or with the equivalent of kubectl replace. And then you update and you rolling update your cluster. And that is and then when you're done, you delete your cluster. And so that is kops in a 10-minute nutshell.
Cool.
Very nice. Mute. I think we are mute. Yeah.
I've got a few questions. Maybe other people will too. The first question that jumped to mind was actually when I saw you do the kind of the rolling update and the drain and all that kind of stuff. Would I be right in thinking that the logic for all of that is actually kind of general purpose within kops?
The logic is general purpose, exactly. We have a little like per cloud provider functionality, which essentially finds out the instances that are actually running and knows whether they're a master or a node, but then and can shut them down. But then yes, the logic of I'm trying to remember the order: cordon, drain, shut down the node, wait for new node, wait for pods and stuff to reschedule and everything to become healthy is generic. And hopefully we can work with the machines API. I mean, that can either become hopefully we can, that's another place where we can work with the machines API and get that logic, or at least the learnings, if not the code, then the learnings into that generic controller, because it's fairly tricky logic and there's absolutely no reason why it should be part of only in kops, right? Every one of these should behave the same way.
Yeah, I love to have actually, take a look at your code and kind of work with you. We started, and I think a couple of weeks back we had one of the SIG cluster lifecycle meeting was about the state machine, and it seems like you implement a lot of that, right? Like how we would do that. So we are starting tracking some of the work that are on that, and we want to get started in the next kind of week or so. So let's work together on that and how we can port some of the lessons at least.
Yeah, that would be great. I mean, definitely reach out to me. And also Chris Love actually wrote a lot of the code. So Chris Love CNM is the other guy that actually wrote most of the rolling update and drain logic. So I guess we should definitely sync on that. And I mean, I would love to use a standalone. The other thing that I think would be great in kops is we only really need to bring up the masters and then have the machines bring up a machine controller on the masters, which brings up the nodes. And I think in the same way that, the add-on manager will let us put more into the Kubernetes API, having the machines controller run the machines means that you don't have to use kops to run the machines, but to tweak your machine configuration. You can do that through the kubectl API, or the Kubernetes API. So yeah, it'd be great to get that happening. The masters is going to be the tricky one, but yes, for the nodes and stuff, definitely we should get that going. And I was going to say, yes, so I have a proof of concept machine controller which leverages kops. It currently uses VMware, ironically enough, but yes, it is not too hard to retrofit or to get a machines controller using kops, and so I'm optimistic we'll get the machines API and the machine controller, or a machine controller for kops working soonish.
Cool. Another kind of just a fuzzier question. So when you implement, I'm thinking this is kind of like as a backend, like the GCP backend, it provides, like you're saying, some number of base features that then a high level logic just uses. When you implemented that backend, what bits made it like tricky and difficult to use, and that you had to work around or invaded your higher level model with bad like leaky APIs or what have you?
Yeah, I mean so there are different systems in kops, right? The rolling update is one system, and I think we only support it currently on AWS and GCP, and both of those support rolling update on AWS and GCP. Both of those support automatic replacement of nodes. So that is so all we have to do is basically terminate the node. So we terminate the instance. We discover the instances, map them to nodes, and terminate them. That's a fairly clean separation. And it will be less clean when we have the first rolling update cloud provider, which does not support, where we have to actually go and create the replacement nodes directly, rather than just waiting for them to magically appear. The other bit, though, the COPS update cluster side, that is remember the sort of list of things it was going to create? Let me see if I can still be my scroll back. Oh, I'm not showing my screen anyway. Remember, it created all those objects like a managed instance group, firewall rule, persistent disk. So those are entirely cloud specific. And I think that is always going to be the case, that the way you create the actual objects on the underlying cloud provider is naturally going to be very cloud specific. And people have pretty strong preferences, particularly when it comes to networking. And at least in COPS, we have the ability to output Terraform and CloudFormation on AWS. We decided not to work with Terraform directly, but effectively re-implemented a sort of smaller version of Terraform. So we have a similar model. Like COPS obviously COPS has a managed instance group type and object, and Terraform obviously also has one. And we can transform the COPS one to the Terraform one, but we also have logic in COPS that actually goes and applies that without using Terraform. I don't know whether it will ever really be the case that we are able to have a fully generic system, but I think we're getting closer with the idea of like KubeADM and the Machines API and all of these things, where the machine controller will bring up if the machine controller is the one that's responsible for the general creation of the cloud resources and creating the machine and handing off, I guess, SSH or whatever it is to whatever the common API is, then I can imagine that everything from then on will be fairly standard or fairly common across clouds. We have that today. Like we have NodeUp, which is our KubeADM-like thing. It embeds KubeADM, and it works the same. It's the same one that runs on all the clouds. It obviously has cloud-specific logic it has OS-specific logic because, for example, Container OS. So we were running Container OS there, and Container OS has its own requirements around certain volumes or certain directories being read-only and no exec, and so we have to put things in different places and do different things based on the OS.
Mm-hmm. Is it possible to select other OSs quite easily, or is it?
Yeah, we can. Let's see. So COPS. Oh wait, I'm not showing my screen anymore. But yes, you can. At least on AWS, we support. We support CoreOS, whatever that's called now. RHEL, CentOS, Ubuntu, Debian. On GCE, we support Container OS. I may be forgetting some, but Ubuntu, yeah. So yes, we can certainly. You just basically select a different image. The interesting thing is COPS. The command line tool doesn't really care, and it actually is quite hard to know what the image is. At least on AWS, you don't have a nice indication of what that image is. And then NodeUp is the one that goes and tries to figure out what OS am I actually running on, and where should I put things based on that. So it's fairly easy to add support for a new OS, modulo the fact that some OSs don't have very different requirements. Like adding support for Container OS was hard because of all the read-only volumes and the mounter thing.
Yeah.
That makes sense. Does anybody else have any questions?
I do have a question. You talked about add-ons manager. We just started discussions around that as well. And Brian Grant mentioned that you're interested in this space. Can you explain just to kind of briefly, what the add-ons manager does in COPS?
Yes. So the COPS add-on manager is pretty similar to the add-on manager that is in the old KubeUp, when the KubeUp scripts, the cluster add-on manager, I guess you'd call it, with the exception that we keep track of what version of an add-on you have installed. So if the user goes and edits an add-on, it won't get reverted 5 minutes later. that was sort of annoying for end users or confusing for end users. But beyond that, it really isn't great. It's still hard to tweak the configurations. And so like reading Brian's proposal around declarative application management, I think it's called, where he essentially uses the Kubernetes API to layer on tweaks. That seems like a great approach to me. So currently all our tweaks, so for example, you might change Flannel from UDP to VXLAN or VXLAN to UDP. So currently those tweaks have to be expressed in the kops cluster. And that's a bit of a pain and not really what users want. Well, maybe in that particular example, they do want that, but it's certainly not what we want to do for all add-ons. The other real problem is that right now, all those add-ons are baked into kops itself. And we both don't want to bake them into kops, and we don't want to be the ones to maintain it. It's hard to maintain all these different, the networking ones are a special source of work. And it would be great to have a Kubernetes agreed way to do the system level add-ons, these sort of very low level things that it's too early in the boot up process to punt it to something like Helm. But we also don't want, KubeADM and kops and GKE and EKS and Azure's thing to all like implement their own versions of the add-ons and have slightly different ones that are all slightly different, broken in slightly different ways. So yeah, there's also, I think Brian pointed me the other day to the K-inflate stuff happening in the kubectl repo. I've been playing with that. The hope is that kops will essentially put add-on management into that sort of style, and then you will be able to, like, kops will still install add-ons as it comes up so that you have enough, so that you can get to the Kubernetes API prompt, but you won't be required to use kops to manage them from then on. You'll be able to use the generic tool, and you'll be able to modify things using these overlay type files. So if you want to change the memory allocation, you can do that.
Cool, thank you.
Justin, maybe you also, since you are working on the ads-on, not ads-on manager, recently ads-on the scaling issue, resource management issue, maybe you can introduce a little bit?
Yeah, the scalar work?
Yes.
Yeah, so the scalar work is pretty separate from what's going on in kops, I guess. But
yeah.
I've also been looking at I will bring it up and then I will share my screen. So on my, I guess this one's on my personal repo. It is GitHub, justinsb.com. All right, share, desktop, share. So thinking a little bit about how add-ons work in terms of sort of the system level add-ons work in terms of the scaling. So this is something we hit a lot. It's hard to find add-ons that, it's hard to pick configurations for add-ons that work at both small scale and large scale. Mm-hmm. So we want to support, running on the smallest instances available on AWS and GCE, but we also want to make sure that it has the capacity to scale up so that the add-ons are not a performance problem as you get to bigger clusters. And we have seen this happen in the real world where, we were setting limits that were too low, in particular for Flannel, when it was using the mode where it had to go to user space to steer traffic. And that had some pretty odd behaviors when you got to bigger sizes. So this is a project called the Cluster Proportional Vertical Pod Scaler with Kubernetes, where Tim Hawken has been helping me figure out what this should look like. But it's essentially the idea that taking the idea of the kubedns autoscaler and making it a generic scaler that can work as a controller. So you can have one controller that is able to configure various add-ons and scale them based on certain inputs, like the number of nodes in the cluster, the total number of cores, the total amount of memory, in theory, any sort of thing like that. So I'm just going to try to find an example. So for example, here's something very similar to kubedns autoscaler, but it is its own API type, and it targets the kubedns deployment. And so the one controller will scale kubedns, the DNS pod, based on the number of CPU it will scale based on the number of cores. It will change the CPU limits and requests for the pod, and we have some notions of quantization and smoothing to try to stop, as everything happens quickly, to stop flapping. During a rolling update of COPS, for example, your nodes are going to go up by one, then down by one, up by one, down by one. You don't necessarily want to bounce all your kubedns pods all the time. And so I will say that Tim and I are still iterating on the exact nature of the API and trying to figure out something that makes sense. And then even after we've decided that, I still have to go and talk to the autoscaler folks who have similar ambitions. So I see it as a prototype that will hopefully mesh with what autoscaler is also working on. The autoscaler, how it really differentiates from autoscaler is in the same way that add-on manager is sort of too early for something like Helm. Currently, the autoscaler relies on a bunch of infrastructure which we don't necessarily want to rely on for the system components. And it might be that we change that in the autoscaler and have a fast path or a direct path or something, but this is a prototype to figure out what works and what makes sense for autoscaler, and trying to make it so that the system add-ons can work at sizes small and large.
Cool.
I have one question about the upgrade process. Is it always in a rolling manner, or can you do something like pool by pool where you scale up the new nodes so that your pods only have to travel one time from one node to another instead of multiple times?
Yeah, so currently you can do it instance group by instance group, which is so you can do your nodes separately from your masters, or you could fake it by bringing up you can have multiple instance groups if you want to mix instance types, for example, but a nice use case of that might be you bring up the new one and you coordinate them and you do it manually that way. I think there is a PR to do a full doubling in size, as it were. To be honest, sort of trying to avoid doing that until we get more harmony with the machines API. I feel like it is a real use case and it's important. I think though we're trying not to build paint ourselves into a corner too much before we know exactly what we're going to do there. But yeah, it is a relatively easy thing to tweak. I think the only debates are about should it be a flag to rolling update, or should it be more like a deployment where you specify it on the API object itself? And I don't think we know. But yes, currently it's one at a time, and that will, pods can bounce repeatedly. An unlucky pod could bounce n times, maybe n-1, but order n.
Any other questions for Justin?
Do you require the instance groups, for GCP or maybe the scaling groups for AWS, or do you do any kind of direct machine management?
As of yet, no direct machine management, but that's really interesting, I think. So the managed instance groups and AWS autoscaling groups are great, and blah blah blah. But if you're in the Kubernetes API and have visibility into the scheduler, you could maybe make decisions that are more aware of what instance type you need, or things of that nature, or which particular instance to shut down. And the generic heuristics that we can express in an autoscaling group or a managed instance group are less good than we could do if we launch instances one at a time. And so I think that the managed instance group does two things, right? It both acts as a reboot, like a watchdog. So it is something that will launch the first instance, and it can do the scaling and replacement. And I think the scaling and replacement and launching of instances is something that we could do better from Kubernetes itself. The watchdog type thing is, so right now you can, I can go in and I can shut down every node in that cluster, and 2 minutes later it'll all come back, and you won't lose any. Yeah, you won't lose any data. Fingers crossed. But all the data lives on persistent disks in etcd, and everything will come right back. And that relies on managed instance groups to restore it. And so for the bottom turtle, I think we want a managed instance group. It could be that the managed instance group actually goes and launches those machines directly. But certainly for nodes, I think it makes a ton of sense to move to a model where we launch instances in a more advanced, in a more aware way, or at least have that option. It would also be cool to, like, based on GCE, where you can tweak the amount of memory, right? Pick a node that has what we believe to be the optimal combination of memory and CPU based on what we're actually seeing in the cluster. That sort of thing, which is something you can't do in managed instance groups.
And I have one other question, if no one has questions. So you've been have a lot of experience with AWS. How was the experience actually working with GCP and putting all the those pieces together? Like, what didn't work that well? What worked well?
It actually worked great. I mean, I think there were some interesting things around ACLs and IAM permissions that were, I guess, different. I think AWS IAM is not exactly easy either. So it's more just like the learning curve on that front. There is a big difference in terms of the ACL permissions on Google Cloud Storage, which actually was fairly involved to fix. So we had to work around something, which was a good change to make, but it's hard to do. It was just so one of these things that compounds 10 times, 5 steps. It's hard to do. You can't give list permissions except at the bucket level. You can't have more than 100 ACLs on the bucket. We wanted to do cross bucket to get it working in E2E in Boscos. They have more than 100 projects. And so when everything worked great until we hit our 100 project, and then suddenly 1 in 100 started breaking, and then 1 in 101, and on and on and on, whatever it was. So so it was yeah, that was a gotcha. Other than that, I think everything actually works pretty well. I think there was one trick which Dawn helped me with about launching an auto scaling group, a managed instance group, sorry, with no instances, which is just a magic thing. But yeah, it's been actually really great.
I think adjusting oversimplify. Actually, I think a lot of things we could improve. So give him a lot of trouble. Some it is because he just mentioned there's the need to improve in underneath infrastructure, but most it is after we didn't document very well. A lot of places it is we saw that we don't have this feature, then we have to go ask around, and then we found actually features support, but there's the hidden configurations to enable those features. So give him a lot of trouble actually, and it turns out we didn't really clearly say we have this feature support and the timeline when support, and I think there's some new release we saw that it's not enable yet, but actually turns out it is working. So some several things actually give him a lot of trouble. So and I think you also, because you filed a couple issues to the GCE, maybe you file directly or I help you file. But anyway, there's a couple things for enhancement and also document.
But the response time was great on those, and maybe that's because Dawn was kind enough to. They came from Dawn rather than coming from me, but there are issues on the AWS side which have lasted for years, which are just out there, and everyone would love to see fixed, and they're gradually getting fixed. But the response time, the velocity definitely seems to be great on GC.
Cool.
Thanks for this one. So last time we talked about, because we paused this one because we switched to add-on scalar, right? So we're talking about to using this one to provide the real services on top of the GCE, the Kubernetes services on GCE. Sorry. So there's a couple of things that we have to promote this to beta, And another thing we talk about to retire off the kubeapp script, and then we can use in the pre-submit to using COPS to block off the pre-submit today on the GCE. So all those kind of things we may need to come back after that as a manager, and we come back to talk about more. And there's some other thing we talk about before, also COPS on the vSphere or something like that. I don't know, so I'm not sure.
There is. I'm going to. So I'm using. So the Machines API work I've been working on. Actually, I've been tying some of that into bare metal, and so I have a little demo of targeting vSphere, which I think I will put on the agenda for the Machines API for Wednesday week, the 14th of February. That's my target date for demoing that. But yeah, vSphere and stuff is actually coming as, and vSphere is like my way of testing bare metal, basically. It doesn't. It's the cheapest way I found to test bare metal.
Yeah. Thanks. That's good.
Okay, well, looks like we're slowly wrapping up on time. At the last chance for a question for Justin. Cool.
Thank you so much. It's been great. These are great questions as well. Like really grilling me. That's great.
Thanks, Justin.
The very last thing I'd add for anyone who's watching this is if you have any questions about GCP in general, or there are things that you'd like to see people talk about, maybe present and discuss, or if there's something you'd like to discuss yourself, please get in touch. The mailing list is all set up. You can ping me on Slack or drop me an email or whatever, and I'll very happily set something up. There's a pretty wide open schedule right now. Other than that, have happy weeks. Right.
Thank you.
Justin.
Thank you. That was fun.